machine learning and artificial intelligence. I once again welcome you all. This is Rishabh and I'll be a trainer for artificial intelligence as well as machine learning. Yeah, let's get started with this exciting journey. Yeah, and to check what are the key ingredients of AI. Yeah, so the main USP of our training, folks, is that we start from the very base stepping stone, right? We don't assume that you come from any background, right? It's completely a new fairy tale world for you guys, right? So don't worry about it. We will completely take care of the prerequisites, right? So we don't assume anything that you come from a specific background, yeah, or you do have any kind of prerequisites. Cool. So before getting started, folks, let me tell you about this particular session that at the moment, folks, you all are kept on mute. At the moment, you all are kept on mute. Yeah. So if you have any questions, don't worry. I'll come to each and every one of you every 15 to 20 minutes just to take your queries and whatever doubts you have so far about this particular course. I'll explain you about the curriculum also while explaining the slides that what are we going to cover in this particular curriculum, yeah, in this particular course. And meanwhile, I'll be taking your questions as well. But at the moment, just hold on to your questions. I'll come to you and you can ask any questions that you want. Speak your heart out, folks. So, I generally tell my students that when you are in this particular topic, your mind should be open, your heart should be open, right? Whatever questions, whatever silliest questions you have, yeah, please shoot. You're free to shoot at any point of time. Yeah? Cool. So let's begin. Right? So just a brief on mine, folks, that I was based out of London for a long time. Very fortunate enough to work with the founder of Hadoop, that is Dov Cutting in Cloudera. Have done many trainings into data science and machine learning. Artificial intelligence, I have just started since past 1.5 to 2 years, because deep learning and the libraries like Keras and TensorFlows have prospered a lot since past 2.5 years. So since past 2 years, I've been doing the trainings onto artificial intelligence with a couple of companies like Accenture, IBM, and a couple of the big fours, right? And I have been doing corporate trainings across Asia Pac and Europe, right? So majority of my trainings and my students were from London prior and from Europe, yeah, but I have recently shifted to Bangalore due to family reasons. I'm doing the consulting stuff from here, and as well as I do trainings apart from this. Training is my passion, right? I'm a committer into Hive, and I basically have created a couple of modules into MongoDB as well as a product. Right, so this is my brief background. People who have already gone through my sessions into big data and data science would be knowing me very well, right? So, yeah, because big data, machine learning, data science, I've been doing it since over 5.5, 6 years, right? Artificial intelligence is one of the finest things at the moment that is a keen interest to me, right? And most of my research work at the moment is going into neural networks, especially the GANs, the generative adversarial networks and all, right? So let me clear the base. Cool. So let's begin. What and why? See, basically, folks, sometimes I hear the term artificial intelligence being very loosely used with machine learning. Yeah, artificial intelligence very loosely used with machine learning, right? People often get confused. Hey, is machine learning artificial intelligence? Yes, it is, but it is a subset of it. It is just one of the part of it. there are many layers attached to artificial intelligence, like deep learning, reinforcement learning, all of them, right? So let's see them step by step what they are. First of all, who is us versus them? Us is humans, Homo sapiens sapiens, and them are machines. Boom. Yeah. See, we learn from experience. Humans do learn from experience, and machines learn from data. The inputs given, yeah, the inputs that you are given to the machine. Fine. You feed in a robo, and the robo behaves in such a way, right? Cool, right? We have seen many movies onto that, like Transformers, right? You feed it, it behaves in such a way. You program it, it behaves in such a way. Based on your experience, program it, experience, program it, experience, train it, yeah? So it's all about training. It's all about training. Yeah, I'll just give you an example, folks. Remember when we were students, I'm talking about the school days. We are lifelong students as such, but consider in our school days, right? What used to happen that teachers used to teach us for the year long, and then we used to give examination based on that, based on the training and the experience and the practice that we have done so far. At the end of the year, we have to give an examination. Correct? Yeah, we got to give a test. Yeah. So basically, teacher is the one, we call it over here as a data. Yeah. Teacher teaches to whom? The student. In this case, student is our robo, our model. Yeah. And teacher teaches based on her experience, right? So this is the training that we give to the student, and then the student performs in the examination and we check the accuracy. Same thing happens with machine. You train the machine and finally you test the machine whether on an external data set that whether the machine is working well or not. It's just like, teacher has trained us on several topics, on several examples, yeah, of the same concept. But of the same concept, different data you get as a question in your examination. And you get that, you take it, proceed further, right? Fine, based on your experience, based on how the teacher has taught the student performs in the examination, right? That's what machine learning is all about. Machine learning is you feed in the data, tell the machine that, okay, based on this input, you get this output. Based on this input, you get this output. And then, finally, machine gets trained that, hey, if this kind of a generalized input, if I get it, I get this kind of an output. Got that? Yeah, got that? And it's applied everywhere. It's applied everywhere. Right? Let's take the example of real estate, folks. See, till now, what has been our experience into real estate? You stay in any damn city, be it Mumbai, San Francisco, Paris, London, Madrid, Copenhagen, anywhere. Yeah? Let's say we take any specific area in that particular city. So do we have a human calculation, a basic human calculation that, hey, if the area of the house increases, the property prices rises? Yeah? Can we have that kind of a determination from our past experience that, hey, if the area increases, the price increases? Correct. If area increases, price increases. Yeah? Cool? That is one such input feature based on which we can map our output feature. Yeah, definitely. Fine. Cool. So, close to work, no traffic, power backup. These are other amenities based on which pricing also can be decided. But let's take at the moment one input feature. Area versus pricing of the house. So you see, this is the data point that I already have. Fine. So if I get any external data, or let's say someone asks me, hey, can you predict the price if the area is so and so square feet? Right? Let's say the area is 900 square feet. Predict the price for me. Right? So definitely what I'll do is, based on this x and y axis, I'll just create a line passing through them, and then I'll see where my 900 square feet is touching the price. Right? You see, a line I have drawn, this is called a slope. Yeah, this is called a line best fitting the data. Yeah, it's called line of best fit. Best fitting the data. Right? Now if someone asks me, hey, tell me, yeah, 45 lakhs, what's the price basically? Yeah, the price is 45 lakhs for that particular square feet. So basically, with this small input feature, one single input feature, we are able to guess the price in an approximate way. Obviously, it won't be bingo, it won't be 100% perfect or accurate, but we are almost nearby that. Call that? Yeah, this is called linear regression. Simple linear regression. Just based on one input feature, we are able to determine the output. Yeah, regression. Regression basically has a formula available. Yeah, there is a slope formula available for regression, and we call that as y equals mx plus c. This equation we have studied in our school. Yeah. So guys, how is our training pedagogy? In this particular training, how we teach our folks? That's very important for you guys to know. First of all, folks, what we do is, for each technique that we take, we understand the basic mathematics lying behind. Basic maths for that particular technique. We study the mathematics behind that technique. Then we study its conceptual understanding of that technique. Yeah, we visualize it. Yeah, based on the applications, and finally we do its source code, sample code of it. Yeah, we write the source code for that particular technique or application. Cool. So we always get started with basic math lying behind that technique. That is over here. When we start with regression, we'll study this particular equation in depth. Got that? Cool. Because machine learning, artificial intelligence, under the hood, if you see, it's all mathematics, pure mathematics. Fine. We'll start with that level. Cool. Now, generally if people ask me, hey, can you tell me what is machine learning, the types of machine learning? Guys, in 80s, yeah, in 80s, people used to classify machine learning as two types. One is regression, another is classification. Regression that you saw, and another type is classification. These are the two types of machine learning techniques that were being classified in 80s. Yeah, in 80s. But in 90s, what happens? What happens in the 90s then? Yeah, in 90s, a general classification came. Yeah, that basically machine learning, you classify it into supervised, unsupervised, and reinforcement. Yeah, supervised learning technique, unsupervised learning technique, and reinforcement technique. I'll come to that later. First of all, let's see this classification model. You know, guys, every day you guys are doing the classification. Every day, believe me, you guys are doing the classification, but you don't know under the hood it's happening. Yeah, you get a mail on your Gmail of some credit card, and you are not at all interested in credit card. Just I'm giving you a topic. You are least interested in credit card mails, especially. So what do? You spam them. Fine. So what happens? Our Gmail gets trained that hey, if credit card emails are coming, you are spamming them, spamming them, spamming them. So it checks the subject line. Yeah. Checks the subject, its relevant contents, and spam it accordingly. It will spam it accordingly. So you might find it in your spam email, junk email, something like that. So loan. You get a loan? Yeah, you get the loan emails. Everyone is getting it, right? In their inboxes somewhere, you get some loans, financial loans, some other spam emails. We all are getting it, right? So we train our model that hey, if this many times this kind of loan emails are coming, I'm spamming it, right? So here, what's the probability that the next email comes of loan, it will be spammed? Yeah. Fine. The next email, the new upcoming email that would come to my inbox, be it Gmail, Yahoo Mail, whatever you are using, will be spam. Yeah. These are the options. What do you select? Obviously 80% or 80% is the chance, right, that I'm spamming it based on the past experience, right? This is classification. Classification, right? Fine. So when we see classification, one of the basic technique about classification is naive-Bayes algorithm. A naive-Bayes algorithm, Bayesian statistics, is the one from where we'll get started on. Yeah. Now classification also has many types. This is just one type that I told you, right? This is one type, which every day you are seeing it. Yeah, be it as a customer of Amazon, a member of eBay. Yeah, every day you are doing some classification, you are picking some items, putting it into the basket, and finally, what Amazon is doing? Amazon is basically giving you some recommendations. Yeah, let's say I have bought Harry Potter books. Yeah, Harry Potter. So can I call Harry Potter as some sci-fi? I don't think so. Fiction? Yes, I can call fiction Harry Potter. Yeah. So next time if any book on fiction gets released, I get recommendation for the same. Because Amazon knows my taste. Amazon even knows, let's say even if I'm a new user, based on my friends, they can make the interest, you know, how we are connected with friends, based on that liking we get recommendations. Yeah, recommendations are just one way of strategizing the sales, be it Netflix, be it Amazon, be it eBay, be it any mutual fund industry, investment banking, all of them are using recommendations. They are using it, but based on the client's interest. Otherwise, you know, recommendation will not work. You know, you see over here, a simple data I have given you guys. Yeah, a simple data that those who are all teenagers are using a gaming application. People who are in their 20s are using Twitter a lot. People who are above 20s or in the 30s or 40s are using Facebook a lot. Right? Cool. There's just some sample data. I have it. Now, what can give me a clue? Can this gender give me any kind of a clue of if a new data comes in, let's say a male or a female, I can able to classify that, hey, that person will be using Facebook or Twitter or any game? No. Gender is not giving me any clue. it does not give me any clue, while age is giving me a clue. Some clue age is giving me. So I can find out that okay, age is one of the criteria, one of the input feature that is helpful for me. Yeah. So what I can do is I can make a tree out of it, that hey, can I club both of them and I can have a clue on that? That is also possible. I can form a tree, decision tree, which I call it. So in this case, what is the data better? Age or gender? Obviously, age, as we can see it from the data itself. You see, it's giving us very good classification. Fine. So, age, yeah, simplest decision tree that we have found. Decision tree helps us in making many judgments, whether a person will default the loan or not based on the input features given, whether a person will be a defaulter or not. Fine? Good? Cool? So, decision tree. Similarly, admission time. Yeah, let's say some of you would have enrolled in the US universities, gone for MS, masters abroad, right? So people basically for studying are applying to different universities. Now, how the universities do accept their application? Can I don't keep any humans over there and let the machine itself take judgment on its own? Yeah, that whether a student should be admitted or not. Let's leave it to the machines. Let's forget about humans do exist in this world, right? Right? Because that's what's happening, right? These days you are hearing a lot related to jobs getting slashed in the IT industry or job losses happening. Have you ever heard a skilled professional or a skilled person getting slashed from the job? Yeah, or is losing the job? Until unless the business gets shut down, that's a different thing, right? But apart from that, you won't find that, right? Who are getting fired? People who are doing the manual iterative tasks, continuous manual iterative tasks. Because why? Automation has happened, robotics has come in, as well as artificial intelligence is one of the strongest reasons. We are leaving everything to the source code, to the model, to the machine. Because machine can do the same task iteratively with high precision. Human can't do it. And even with lesser cost, why to pay the salary? Right? Cool. Got that. So, might hear a lot, these days manual testers getting fired a lot. Manual testers, why? It's a cakewalk now. Right? So, let's come back to our example, folks. Yeah, so you see, there are different students that I have lined up for you. This is student 1 who is having grade as 8, test score 9 out of 10. This is student 2 whose grades are 3 out of 10, test score 4 out of 10. And this is student 3, grades 6 on 10, test score 7 on 10. You get that? These are multiple students. Different students. Yeah? Got cool? So, you have multiple students. Now, student 1, I know student 1 will get admitted. I have the information student 2 didn't got admitted. But now if someone asks me a question to the machine that, hey, whether a student 3 will get admitted or not. Whether a student 3, I don't know about student 3, it's an external data. Yeah, whether a student 3 will get admitted or not. Let's see. Yeah, let's see over here. One is an acceptance, another is a rejection. And I have this past history of data that I have. Yeah, one of my data set is lying here, another data set is lying here. So can I plot, like in regression that I plotted a line, can I plot a line over here and do some segmentation? That okay, Any data that is lying in the right side of this line gets admitted, left side of this line rejected. Will this work? Do you think will this work? Yeah, this brute force approach, will this work? Yeah. Do you think it will work? I don't think so. There is some goof up. What is the goof up? Yeah. Okay, let's say if I have some student over here. This one. Yeah. Whose test score, yeah, is 9 out of 10, but grades are very low. Grades are very low. Right? Do you think that university will have the slightest of interest to take that student? No, logically thinking, I don't think so. The student should get admitted. So here there is an inaccuracy of our machine learning algo. Yeah, inaccuracy. But right now, let's not get involved in that inaccuracy. Let's see about the student 3. Will the student 3 get admitted or not? If I plot it, test score is over here 7, grade score is 6. So where is 6 lying over here? Somewhere over here. That point will be somewhere over here. 7 and 6. 7 over here, 6 over here. 7, 6. So I think the student has a chance of getting selected. Student has a chance of getting selected. Fine, this is logistic regression where I get categorical outcome. Where I get a categorical outcome, that's logistic regression. When I get a numerical outcome, that's linear regression. Cool. But will this logistic regression work fine always? Let's see. Let's see. In this case, the same thing which I told you, right? Let's say I have another student who has great test scores but extremely poor grades. Yeah? Yeah? So now what to do? What to do? Let's say I have a data set like this. Can I give a linear regression line over here? Yeah? Yeah? I don't think so because there are many data sets. Fine? Which is on the right side of it, which are not accepted or rejected. So, can I do one more thing? As a human, can I draw another line over here? And I say that in this line, for this particular line, line 1, anyone which is in the right side, and for line 2, anyone which is above line 2. So, right hand side of L1 and upper side of line 2 gets accepted. Can I do like that? Can I do like that? I can. I can. This is what human brain teaches us, right? Right? By adding another dimension to it. That's what neural networks is. Adding another dimension. Fine. So how a brain thinks, we get the inputs. There is a hidden layer considered to be our brain, which is working in a very complex fashion, and still some research is going on that how exactly our brain is able to take complex judgment in the final output layer, right? You know, there is a lot of study going on in Stephen Hawking's brain because that person from head to toe, right, leaving the brain apart, everything is damaged of that person, but he's a fantastic physicist. Great theories coming from his head. How? Right? How? Right? So, adding more dimensions. Yeah? Now, you know guys, adding dimensions is fine, but which line is better? This one or this one? Let's say this is also doing a classification. This is also doing a classification between this pink and blue. Right? But which line is better? Which is doing a better classification? Which line should I select? There are, in your real time also, you might have options in selecting the model, but which model to select? Which line to select? Which classifier to select? How you will decide? How? You will decide based on minimum error and better classification. Maximum accuracy. So you see over here, this line is giving us more gaps. Yeah. While if I take another line, this is also giving me good gaps. So which line shall I select? The yellow one or the purple one? Yeah? Which one? That's what support vector machine helps us. Support vector machine has some kernel trick which can, what it does is, it will completely have a glass view of the data. Glass view. That means the same data, can I represent that in three-dimensional data? Instead of 2 dimensions, can I have a 3D data and add dimensions and have a proper classifier over there? Instead of just giving lines or regression, can I add a dimension or a kernel? Yeah, I'll come to kernel later, what is a kernel and all, but it's just adding dimensions. 3D, it's basically, let's say you go for a medical checkup, sometimes X-ray doesn't give you a proper review. What do? You do MRI scan, right? Because that gives you the entire nitty-gritty of what has happened in the body. Each nerve, it can pick it up, right? So this is considered to be the MRI scan of machine learning, support vector machine. Got that? Cool. Hungry. Let's see if I've got to figure it out. Where I get the chicken biryanis, right? I am staying in a particular area. I don't want to travel too far, but I am conscious about specific brands. I want a specific brand, right? I have it. I have the data set, the data points, and that data points gives me area-wise where that particular brand is distributed. Now I need to pick and choose which area shall I go, right? So clustering, one of the basic clustering technique is k-means clustering. K-means, yeah, k is nothing but how many clusters you want. 1, 2, 3. So here k is 3. K means clustering, right? Cool. So how the distance between the cluster is decided? Based on the distance. That distance we call it as Euclidean distance. Yeah? How we can say a particular data set is near or far or together or not together? Based on Euclidean distance. Based on Euclidean distance. Euclidean distance will tell me or give me a clue that it's x2 minus x1 square plus y2 minus y1 square. Yeah? Fine. So if I want to designate a point for each cluster, representing a cluster, characteristics of the cluster, what I'll do, initially random points I'll select in the graph somewhere, and then I'll try and change based on the centroid. I'll figure out the centroid, and then I have a point which showcases that particular cluster. This is the centroid of this cluster, centroid of this cluster, centroid of this cluster. Yeah, good. So this continuous changes I'll be doing in such a way that until and unless it converges with the data. That's called k-means clustering. Cool. So as I told you, artificial intelligence and machine learning is very much entangled to each other, but machine learning is just a subset of it. If someone asks me about AI, generally I say, yeah, and it's my definition that the brain, the real brain of artificial intelligence is deep learning, the neural nets. Yeah, and the actual hands and legs of artificial intelligence is reinforcement learning, which gives the locomotion, right? So these are all the pillars of artificial intelligence. So machine learning is just a part or a subset of it. Actually, this is the complete artificial intelligence periodic table. Yeah, periodic table we have seen it in our chemistry labs, right? Or the elements, all elements. So these are all elements of artificial intelligence. Yeah, nothing can be taken out. When you know all of them, that means you know something about AI. Got it? As I told you, this is the brain of it. Now in deep learning, folks, many techniques also will be seen. So we'll start with machine learning as our core foundation for this particular course. Step by step, we'll approach towards machine learning, and then gradually we'll move towards deep learning. Yeah? So in machine learning, what happens? Many things you need to do it manually, feature extraction, classification, all that. But in deep learning, both of them are entangled together. Both of them are very much entangled together. Feature extraction with classification. And finally, you get the output out of it. Yeah, so these are some of the techniques, folks, in neural nets that we'll be seeing. Got that? Yeah. And these are some of the use cases, folks, that we'll see in our deep learning. Image recognition, we'll see that how translation can happen, how Google Translate actually works at the back end. Yeah, fine. How recommendation works with the help of deep learning. And let's say you speak something, let's say, you type in Google, yeah, dog walking near the sea, and you get the images related to that. Yeah, that's one of the fantastic use case of deep learning. That based on your words, it can plot an image, and based on the image, it can even give you the words, right? So let's say if I showcase a Mona Lisa painting, I'll get the complete description of Leonardo, where it is kept in Paris, Versailles Museum, etc., etc. Yeah, cool. Call that. So many techniques are associated with it, like convolutional neural nets. How you take or analyze pixel by pixel and get an information out of an image. Recurrent neural nets, how you do the speech synthesis and all, right? So these are some of the techniques of deep learning that we'll be studying in depth. And reinforcement learning, a latest entrant in the TensorFlows and the Keras. And you would love reinforcement learning, folks, frankly speaking, because, as such, we all are greedy people. Yeah, human beings, we all are greedy. How we make our judgment? We make our judgment based on the reward. Yeah, I'll just give you a very simple example. And we are greedy from birth. By birth, we are greedy. It's not that we have become greedy over a period of time. No. Just I'll give you a very simple example. Let's say you are a student. You are a student and you are trying to attempt You're giving an examination and you are just left out with 5 minutes. You are just left out with 5 minutes. Got that? And you need to answer only one question. You have time to answer only one question. You have time to answer only one question in these 5 minutes. Now, one question is of 15 marks. Another question is of 20 marks. You can finish any one of them. Which one will you pick? Obviously 20 marks. Why? Because it's giving you better reward. More reward. So based on your reward, your policy is decided, and based on your policy, you take the action. Based on your reward, your policy is revised and decided, and based on the policy, you take the action and attempt the second question or answer the second question. That's what reinforcement learning is all about in short. Right? So these are different techniques of doing reinforcement learning, folks. Monte Carlo and all, we'll be seeing that. And reinforcement learning is one of the pioneer technology in self-driving cars. These days, you all would have heard of concept of self-driving cars. Yeah, have you heard, all of you? Yeah, I have already seen self-driving buses in Amsterdam, in Netherlands. Yeah, it has already started in some of the villages in Netherlands. Yeah, you won't believe, folks. It's not US, it's not Canada, it's not any other country from Asia. It's Netherlands, which is one of the most innovative country across the world. Early adopters of any technology, seriously. I've seen it. I have traveled across the world, but any new thing, they are ready to experiment it. Yeah, seriously, those guys are brilliant geeks, right? The Dutch people. So, this is how it's being decided. Based on the reward, yeah, we revise our policy and take the action. Got that? Cool. You see? A brilliant example. Where you go? Near the water or near the fire? Yeah? Yeah? Getting the clue of reinforcement, folks? You can read these 6 steps. And that's what AI is all about. So here we need to reach, folks. We'll start from very basic machine learning. We'll study the Python libraries, pandas, scikit-learn and all. Gradually move towards TensorFlow, Keras and all, and try and implement deep learning and reinforcement learning with those libraries. It will be fun. If you would have loved mathematics in your school days, this is literally going to be fun. I'm going to make it as simple as possible. Yeah, but I need your support, your enthusiasm. Main thing is your enthusiasm and passion to study. Rest all leave it to us. Right? At least I need an enthusiasm. I need questions from you guys, yeah? It should not be, you should be just passive students. No. Be a bombarding student. I love that. Right? Cool. Yeah? So questions time, folks. Questions time. Anyone having any questions, please click on the hand symbol. Please click on the hand symbol. I would love to talk to you. Any questions that you have, folks? Any damn question. Anything. Speak your heart out. 2 plus 2, you can ask that kind of a question also. Yeah, please speak your heart out and click on the hand symbol. Those who are having any questions, please click on the hand symbol. I would love to talk to you. Yeah, let me first come to Krishna. Yes, Krishna? Krishna Gajula, speak up.
Hello, yeah, this is Krishna here. So I just want to know whether is Python and any other programming language mandatory for this?
See, basically, we'll start with Python, learning Python. Yeah, because Python is something which is at the moment core to machine learning these days, and it's a core to artificial intelligence, and the deep learning libraries also that you see are all built on Python. So we'll start learning Python first. It's scientific libraries. Don't worry if you don't know about Python or any coding language. Python is very, very easy to code. Even these days, school children are coding in Python, so don't worry about that. We'll make you learn at least what is required for machine learning and to study the scientific libraries, and gradually will progress. So if you don't have any background in Python, don't worry at all.
Okay.
Cool? Yeah. Now, let me take a few questions that I have it in the question box as well. Yeah. At the moment, any certification is present in artificial intelligence? No. There is no certification present, folks, as far as any vendor of AI is concerned. Yes, there are private certifications, but no actual any global authority or any global vendor who is providing any certification in AI. Yes, for machine learning, we have certifications. For data science, there are people like Cloudera and all giving the certifications, but for AI, we don't have it. Yeah. I've got a question from Mahdi Fatih. Could you introduce Python's resources? Yes, we will be seeing libraries like Pandas, NumPy, Scikit-learn. Yeah. So from session 2 onwards, this is demo session. The next session is session 1, and from session 2 onwards, I'll be introducing you to the Python libraries, the basic libraries that we should know, like Pandas, Scikit-learn, and you will get all materials as well from our end. So don't worry about that. The slides, the PDFs, all the assignments, you will be getting it from our end. Many of the things we'll be doing it during course itself with us. You guys will be doing the hands-on. Yeah, and I'll be giving ample amount of time. Don't worry about that. But some as homework also will be getting during the weekends or so. Yeah, because I do understand you all are working professionals. You all have your own work commitments. Yeah, so I won't keep you much busy during the weekdays, but definitely I'll make sure your weekends get spoiled. Yeah, just kidding. Yeah, so yes, you got to be with us. Cool. Don't worry. Even if you miss out any session, guys, you can get the recording from our team. Yeah. So what is our team? This is our team. You can contact them at any point of time for any other details. Yeah, they're 24/7 available. Even if you want to get in touch with me, you can collect my contact details from them. They'll provide it to you. Yeah. So they are 24/7 available, 365 days, folks. So please be in touch with them. Yeah. And don't worry. So I've got a question from Tilak Chand that, hey, I am from a manual testing background. I don't have any background in the programming skills. Don't worry, Tilak. In our previous batch, there were around 10 people into AI who were from McKinsey. They were nowhere related to any kind of coding. Yeah. Fine. At least you would have done some Linux commands. Those guys have not done anything. They were all pure business analysts. Right. So don't worry. They all have attended our AI trainings and have started the pillars in McKinsey itself, right? So don't worry about that. We'll take care. Yeah. I got a question from Kanchan Pal, where we can use this artificial intelligence, because I see after 5 years now, still banks and companies are not willing to adopt big data fully. See, big data and AI are different things. If you ask me, big data, see, I have been with big data since its inception, since the birth of Hadoop, frankly speaking. Why the banks were hesitant, and I can tell you about the scenarios in Canary Wharf in London, because Canary Wharf is just like a mini Silicon Valley of banks, right? All banks, you will find it over there in Canary Wharf in London, like HSBC, Santander, Barclays, blah, 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 all of them. Banks were hesitant because of a couple of reasons. One, there were no mature enterprise vendors available at that point of time. Now there are, but at that point of time it was not. Data governance was one of the biggest issues with the banks. Cloud, another big issue. They wanted to have a private cloud and private infrastructure, everything private. Yeah, data security, role-based authorization. So all these things were concerns of the bank. But I don't think now banks have that big problems what it used to have it 7 years back when Hadoop just came into the market, or Spark just came in. Or now things are getting more mature. Yeah, data governance is also getting resolved. Data governance is always the issues with banks are still even not using the cloud infrastructure a lot. Have you ever seen banks using very much the cloud? No, they have the private setup. Yeah, because banks have to think a lot about the data and all. But artificial intelligence is different. Artificial intelligence is, I go to a bank, I don't need to ask a human person, hey, which counter I need to go for the mutual fund investments or portfolio banking or current account or savings account or let's say loan account or mortgage or something like that. There would be a robo will be able to answer me. Yeah, a helpful assistant will be there. This is just one example I'm giving you. There are many applications of artificial intelligence into banking apart from this. Yeah, so sometimes based on the data, fine, I have a different experience, but based on the credentials, human credentials, the new changes, the new trends happening, I have different opinions for a human. So artificial intelligence can even help us in doing many tasks which is happening in a way how humans are thinking, humans thinking and approach and experience, but precision of a machine, both getting clubbed together. That's what AI is all about. Chatbots, create a chatbot from AI. It's again another application. Robotic surgery is happening these days. Yes, it's happening in Canadian hospitals. That's one of the finest example of AI. Self-driving cars. I'm not saying self-driving cars is a big success, but it's getting in place where the traffic conditions and the rules are in place. Self-driving cars are working fine there. That's not a big issue. Uber is experimenting it a lot. Many of the companies are experimenting it a lot. Like even in Amazon, there is a drone. I just delivered a training. Day before yesterday, I finished a 4 days training of AI over there. Drones, they have a drone team over there. Literally, you won't. Yeah. So sometimes, I even might not be having the applications. I visit a company, yeah, and then they tell me that why they want to learn artificial intelligence, so that from my training they can apply it in their teams, right? So sometimes I know the technology, but I don't have to do that application where it can be applied across domains, right? Banking is just one of the sector. Cool. Got that? Any questions? Anyone having any questions? Click on the hand symbol. I would love to hear your beautiful voice, folks. Yeah? All good so far? Cool? So tomorrow we have the next class, folks. And please do attend. Any questions apart from this related to logistics, timelines? Timelines will remain the same. Connect to the techie team and they'll guide you everything. They are fully equipped, 24/7 available. You can WhatsApp them, Viber them, chat with them on Skype, email them. Yeah, I would say email them. You will get a response within no time. Right? Just check your inboxes, folks. You can check your inboxes from techie team, techie learn team. Yeah, and we'll get all the response from them. That's it for today. Take care. Bye bye. See ya. Cheers.